Okay, so excuse me, we're just looking at the last topic, basically in matrices, in networks, and this is connecting matrices and networks together. So we're looking at a connected network that can be represented by a matrix, and this matrix is called an adjacency matrix. So we're looking at four nodes, A, B, C, and D. And for instance, you can see that A and B are connected by 2, A doesn't get to C, and A is connected to D by 1. So A doesn't have a loop, so A doesn't connect itself. A goes to B twice. A can't get to C, and A has a D connection just the once. So if you have a look through the rest of the network and just see how the numbers in the matrix work, and when you're ready, come to the next slide. Okay, so moving on to the next slide. I want you to have a go at this one yourself. We've got A, B, C, D, E. The only interesting thing is a little bit of a change at E. We've got a loop at E, which means that a loop counts as 2, not 1. We did that before when we did edges. So when you have a loop counts as 2. So when you're ready, have a crack at converting that network into a matrix and come to the next slide when you're ready. Okay, so let's have a look at what the graph looks like. The graph is on the previous page. A, B, C, D, and E. So as I said, the only interesting thing is down here at E, and E connects to itself twice. A loop counts as 2. Okay, all the other paths are pretty straightforward. B and C have a connection of 2, and basically everything else is a 1. So let's have a look at the next. Hopefully you've got no problems, and we'll look at the next example. So we're going to go reverse, and given a matrix, make it up to a graph. So have a look. Again, you're looking at the interesting thing here. A connects to itself, and obviously when it connects to itself, it has to be a 2. You can't have a 1. Okay, A to A can't be a 1. It has to be a loop. So the rest of that looks straightforward. When you're ready, have a draw and have a look at the answer when you're ready on the next page. Okay, so we're looking at the representation. Again, as I said, A to A is 2, so it must be a loop. So A must have a loop to itself. All the rest are pretty straightforward. Okay, let's have a look at the next slide. And this one again is converting a matrix into a connected graph. And just to make it a little bit more interesting, and then count how many regions you have. So make sure when you draw your graph that you don't have any crossovers. You need to have a planar graph, so there's no crossovers. Just make sure when you're counting your regions. So the matrix is there. Again, interesting here, we've got B connects to itself. So if it connects to itself, it must be a 2. You can't have a 1 because we've got a loop, and everything else looks pretty straightforward. So when you're ready, have a go and come to the next slide when you're ready. Okay, so looking at the next slide, we've got A to B with 2 paths, A to C with 1, etc., etc. Again, B connects to itself, which means we've got a loop, and I've drawn a planar graph, so I've got no intersecting or overlapping edges, and then when I count my regions, I have 5 regions. And that's the end of the thing. So on Moodle, you'll have an exercise sheet that I've loaded on from another textbook. It wasn't in our textbook. And have a go at that and see how you go. Thank you very much.